Hi, my name is Kanchan Vaigar, and I'm a solutions architect from AWS Marketplace team. And today, I'm going to share how you can apply machine learning to solve business problems and to add differentiating features via pre-trained machine learning models. First, I'll give you an overview of models and algorithms from AWS Marketplace. And then, I'll share how a machine learning vendor is enabling the financial customer meet stringent guidelines by providing model via AWS Marketplace, followed by a demo on deployment and evaluation of third-party models. As a solutions architect working with customers, I often hear many challenges from customers wanting to adopt third-party ML solutions. There are plenty of machine learning models which are very high quality available from technology companies. But during the initial discussion itself, an important question arises: where to try and evaluate the machine learning model? Does it happen in seller's environment or does it happen in customer's account? Well, the seller wants to protect their IP during and after the model evaluation. And the customer, they want to protect data, which is often sensitive to their businesses. And customers also need to learn seller specific interface every time they try out a different model from a different vendor. Apart from that, there are multiple other challenges which we heard from AWS customers, and we decided to solve them via AWS Marketplace. You have probably heard about AWS Marketplace, which you can use in order to buy third-party software products. Well, you can also find hundreds of machine learning models and algorithms which are compatible with Amazon SageMaker, which means you can deploy them with Amazon SageMaker. You use standard Amazon SageMaker endpoint invocation API interface to interact with these models, which means you don't have to learn a new API interface every time you want to try a different model from a different vendor. AWS Marketplace has a large selection from leading machine learning independent software vendors. And there are also models from some open source frameworks, such as Gluon from AWS as well. There are two types of Amazon SageMaker compatible products that you can find: machine learning models and algorithms. A pre-trained machine learning model is an entity that accepts an input payload and it returns you a prediction. For example, there is a computer vision model which accepts an image of a car and it returns you the make, model, and year of the car in the picture. And then the second type is algorithms. You can use algorithms to train a custom machine learning model on top of your data. For example, imagine that you have a large data set and you want to train a custom regression model. Well, you can use high performance algorithms from AWS Marketplace, such as AutoGluon Tabular, which is an AutoML algorithm without having to learn a whole lot of machine learning. You can explore models and algorithms in AWS Marketplace just like other products. And these models are deployed using Amazon SageMaker in a network isolated manner. And you can perform inference on top of these models via a REST API. You also get enhanced security via different measures. When sellers list their models, static and dynamic scans are performed by Amazon SageMaker to identify vulnerabilities. Amazon SageMaker also encrypts algorithm, model, and other system artifacts in transit and at rest, and it isolates the deployed artifacts from internet access. These containers are deployed in internet-free environment. You can also choose to deploy them in your private VPC and further control who accesses these models. You can also configure and monitor VPC flow logs to see what's going in and what's coming out of the container. And requests to Amazon SageMaker API happen over SSL. And Amazon SageMaker requires IAM credentials to access resources and data on your deployment via an IAM execution role. Also, you can use Private Marketplace and AWS Service Catalog to further control procurement and distribution of this third-party model. Models from AWS Marketplace are primarily used for three distinct use cases. Developers with little data science experience as well as business users use models to build AI ML backed solutions. You can see sample use cases for which models are used on the screen. For example, you can use a machine learning model to perform optical character recognition to extract characters from an image. Data analysts, engineers, and scientists have to manually identify and use only good quality data. And often, this process can be expedited by using an ML model. So let me elaborate. Background noise classifier is a machine learning model which can identify noisy audio files. And then there is a source separation model which can be used to separate the audio from the noise, which means you can actually use these two models in conjunction in order to identify high quality audio files, which you can then use for training your audio ML model. During feature engineering step, data analysts, engineers, and scientists identify and create multiple features to choose from. Well, you can use ML models to generate these synthetic features. For example, there is a machine learning model which accepts a text and it returns you the emotion present in the text. Well, the emotion itself can become a powerful synthetic feature for your book genre classification ML model. Now let me tell you about some sellers and AWS customers who are using models via AWS Marketplace to securely try, buy, and evaluate third-party models. And spend on these models could be applied to AWS commitments. A financial organization, I can't disclose the name of yet, wanted to set up additional gates to support a money lending decision. So they started looking for off-the-shelf ML solutions. However, the evaluation process itself had a few constraints. Since the data couldn't leave their environment because it was sensitive data. And also the model evaluation had to happen in their own AWS account instead of the seller's account. Apart from that, they also wanted to monitor what was coming out of the model container that was getting deployed. So they came across Experian, who has a feature-rich model pipeline that has been used by other identical financial institutions for identical purposes. However, Experian wanted to ensure that their IP was secure during and after the model evaluation, and they also wanted to ensure that going forward, they are able to release a newer version of the model to the customer. And Experian and the customer together decided to use AWS Marketplace as the fulfillment mechanism. By going via this route, Experian was able to enable the customer to securely evaluate and deploy models while ensuring that their IP was protected. Here is how Experian's ML model engine pipeline works. The first model accepts a bank statement and it identifies an expense category, and it also returns a prediction confidence for each transaction. This output can then be fed to a sequence insights model, which identifies income streams based on credits reported in the bank statement, along with the frequency of the income. The output of the first model can then be fed to a scoring model which returns a custom score which can assist in making a lending decision. Along with other important metrics such as trend in discretionary spending, affordability change in last 30 days, 180 days, there are multiple other metrics which are also emitted by the scoring model. Experience models, which I'm about to show you, are in limited access status, and if you're interested in trying them out, please get in touch with us. Now let me switch to AWS Console and show you how to explore and deploy ML models from AWS Marketplace. It is very easy to explore models and algorithms from AWS Marketplace. Open AWS Marketplace and then choose Amazon SageMaker as the delivery method. You'll see a large selection of model packages as well as algorithms. Let me show you how to explore the models further. So let me click on this particular model, and you can see what the model is all about in the product overview section. Under highlight section, you can often also find the research papers it is based on as well as additional information about how the model itself was often trained. If you scroll down further, you'll also be able to understand the software pricing associated with the model apart from the regular SageMaker infrastructure pricing. Under usage information, you'll be able to find the input and the output content type of the model itself, and often an AWS CLI sample command that you can use in order to perform the inference after you have deployed an endpoint. Additional resources section also contains sample notebooks for many of the listings. Many listings also have this try product demo feature, which lets you try the model out without you even having to subscribe to it. So let me show it to you how it works. So I'm going to click on upload an image button since this is a computer vision model, and I uploaded this particular sample image, and you can see that the model identified these two items. First one is a car, and the second object it identified is a fire hydrant right over here. You can see the detailed response right over here. Once you're happy with the model, you can click on continue to subscribe, and you can review the pricing as well as the end user license agreement and click on accept offer button. Once that has been done, continue to configuration button will be enabled, and you can see that you can deploy the model via Amazon SageMaker console or AWS CLI. And there is also a third option available to you, and that is via a CloudFormation template. So here is a sample CloudFormation template that I can use for deploying an ML model. So our today's demo focuses on the CAS model. So this is the model which I'm going to click on continue to subscribe on. And then since I've already accepted the offer, I can simply go ahead and click on continue to configuration. Now, I'm going to copy this model package ARN, and then I've already gone ahead, I've downloaded this particular CloudFormation template, and I've also customized it further by specifying the model package ARN corresponding to the model that I want to deploy. I also ensured that the instance types were compatible with the model that I chose. After this is done, I can simply go ahead into AWS CloudFormation console and trigger a stack. So you can see that I've opened CloudFormation console and I've uploaded the CloudFormation template that I just showed you. When I click on next, I'll be asked to enter different parameters. So I'm going to enter a few parameters. And then I'm going to click on the button next after I have entered all the parameters. After entering the parameters, I can specify whether I want to add any additional tags or any additional configurations specifically related to CloudFormation. Then I can click on the next button, and then I can click on the launch stack button in order to launch the stack. You can see that I've clicked on the next button, and now I'm being presented an option to create a stack. So let me create a stack, and this button is going to actually stand up an Amazon SageMaker endpoint. And you can see here that the CloudFormation template itself has initiated. If I go into the template, you'll be able to see what all operations are happening in the background. First, it is taking the model package and it is creating a model that is local to this particular account, the dynamic model. It is then creating an endpoint config, and then it is standing up an endpoint. And once this particular CloudFormation template has been deployed, the status of this particular template will change for create in progress to create complete, and I'll be able to perform inference directly on top of the endpoint that I just created. You can see the status of this particular CloudFormation template has completed, which means the CloudFormation template has executed successfully. If I go into the template tab, you can see that this template creates an endpoint. And if I go into Amazon SageMaker console in the endpoint section, I'm able to see this CAS endpoint created by CloudFormation template, whose status is in service, which means I can now perform inference on top of this particular endpoint via different methods. For my today's demo, I'm going to perform the inference via AWS CLI. So here is the CLI command that I'm going to type in order to send an input payload that I've created. So this is the input.json, which contains a few bank statements which I'm going to send to this particular endpoint. So when I send this particular information to the endpoint, I get the output in out.json file. I can execute this particular command in order to convert the output into a pretty printed format. And you can see that the out.json contains additional information such as label, subcategory, category, and confidence. You can see that it took this one record and it has performed an inference on top of that record in order to return you a prediction. The prediction includes a value called category, that is, this particular expense, which category does it belong to? In this case, it identified that this particular expense belongs to food and dining category. It also went ahead and it identified a subcategory for you. It identified that under food and dining, this is actually a coffee shop. And then it has suffixed the subcategory to the category and it has created a label column for you. You can also see that it has returned the prediction confidence, which means this particular model is 85% confidence that the category and the subcategory that it has identified is correct. This completes the first model which I wanted to showcase today. Now this particular output can be fed to the sequence insight data in order to do identification of additional insights such as the monthly income or all the other income sources that this particular person has. So in order to do that, now I'm going to run another command. I'm going to actually perform an inference on a sequence insights model which I took the liberty to deploy before recording this particular demo. So you can see that the output of the first model is what I'm going to feed to the sequence insights model. So when I execute this particular AWS CLI command, I get an inference in out_sequence insights.json file. Now I'm going to execute the same tool, python-m-json.tool, on top of this particular file. And then now let me open this file and show you what the output looks like. So here is how the output looks like. You can see that it has identified the monthly median income as $4,200. It has also identified that in last 6 months, this is the amount which was deposited into the customer's account. It also identified that this is the yearly monthly sum. You can see that this particular bank statement belongs to a person who has a steady income. You can also identify other additional income sources, such as maybe the particular customer has does some business on Etsy. So maybe there is, there could be these additional income sources which the model is also able to capture. So we have already taken the bank statement. We've already identified the categories and the subcategories for each of the expense. And the model, this particular model, has also identified the constant income sources, the other income sources, the income sources which are weekly, fortnightly, monthly, as well as some random income sources which are not consistent, such as NHC income. Now, let us perform an inference on the third model. So again, I've taken the input of the output of the first model, and now I'm going to feed this as an input to the CAST score model in order to get a good score that actually will help me understand which way to go, whether to lend or whether not to lend. So let me perform So now I'm going to perform the inference on the third model. You can see that I'm using the output as I just mentioned, and here is the command, here is the AWS CLI command which I'm going to execute now. So when I execute this particular command, I get the output in out.castscore.json. So I'm going to repurpose this particular command in order to now pretty print the output that we just received from the model. Now let me open the output and show you how it looks. You can see that this is the output which was returned by the CAST score model. So if I scroll further here, I'll be able to actually see a couple of information such as different indicators that it was able to find, different matrix that it was able to find. And this is the score which actually is the CAST score which was returned by this particular model. You can also see that it is also able to find other trends such as the total amount of discretionary spending versus total amount of spending which happens every month. You can also see that it also tells you whether the affordability has gone up or not. And these individual indicators belongs to different kind of requirements which different financial organizations may have. So the model is able to perform a bunch of different matrix in order to meet different organizational needs. And that really completes the first part of the demo, which was really to show you how to deploy an ML model and how the ML model engine works. To summarize, I chose an ML model, I subscribed to it, and then I executed a CloudFormation template to deploy the model. And once the model was deployed, I used AWS CLI to perform an inference. You can see how application developers with little ML knowledge can easily integrate ML solutions. While consuming ML models, a key task is to do a deeper evaluation. If you don't have a machine learning background, your data engineering or analyst team can help you do a deeper evaluation, which is a very short activity compared to the model training activity. The evaluation activity can take maybe a couple of hours, whereas the model training activity can take somewhere between weeks to months, depending upon multiple factors such as availability of data, availability of skill, resource availability, and many others. So let me switch into Jupyter Notebook and show you how to evaluate an ML model. To evaluate an ML model, you need a ground truth dataset, a dataset that you use as a baseline for understanding model's performance. The dataset must be large enough, at least thousands of data points, if not tens of thousands. You need to manually label the dataset, and you need to ensure that it is standardized so that you can do one-on-one comparison with the prediction output. You can see that I used the ground truth dataset that I had, and I manually populated the ground truth label column, and then I loaded the dataset in a pandas data frame called df. I've already deployed the CAST model that accepts a bank statement, and it returns a label containing concatenated category and subcategory values along with the prediction confidence. So I went ahead, I fed the a ground truth dataset, of course, without the label column, and stored the response in a prediction._output.csv file. And then I loaded this in a pandas data frame. Now we do the model evaluation. Since the label maps to multiple values, this is a multi-class classification problem. And for today's quick evaluation, I'm going to stick to precision and recall as the evaluation matrix. So I concatenated the ground truth data frame and the prediction output, and you can see that simply by writing these few lines of code, I was easily able to calculate metrics such as accuracy and precision. You can see that there were total 42 unique labels, and I got a precision as well as recall of roughly 96%, which is pretty good. And since this is a quick evaluation, I'm not going to go deep, but you can easily go ahead and plot a confusion matrix or calculate other relevant metrics such as F1 log loss or any of the others that are specifically interest to you. Now I want to analyze how confident is the model. Is the model generally returning high confidence results or not? So I plotted this histogram and you can see that the model is generally confident and the values returned are mostly above 0.8. However, you can also see that there are low confidence ones with 0.2 and 0.4 confidence values as well. And to understand how good the low confidence predictions are, I plotted this bar graph. And you can see that even for 0 to 0.5 band, this particular one, the precision and recall is sufficiently high. This shows that the model is doing pretty well, not only on the high confidence results, but also on the lower confidence results. Most of our expenses are in a few categories. And then there are these random categories which are not so often. So it becomes important that we analyze how well the model is performing for most common categories. So I plotted this bar graph to identify the top few categories, and then I plotted this another bar graph to see the precision and the recall values for the individual topics categories. Often, you also need to analyze whether the model is doing well for a specific few categories. For example, you need to ensure that the model has a good recall for the gambling as a category. Often, you also need to analyze whether model is doing well for specific transactions that interest you. For example, a payday loan and job seekers allowance are two categories that a financial organization might be specially interested in. You can simply check the inference for such results to understand if model is behaving as you expected or not. And that really completes my end-to-end evaluation today. In short, we identified a ground truth dataset, we labeled it manually, and then we performed a deep analysis to understand the model inference matrix. If you're happy with the model, you can directly integrate it with your application. And for addressing low confidence predictions, you can use Amazon Augmented AI. And if you need customizations with the model itself, made by the interface format or specific tuning use cases, you can leave a feedback on the listing and seller can help you out. To summarize, customers use AWS Marketplace to identify ML solutions they can use to solve their ML problems, do quick POCs, and they release new AI-backed capabilities to production securely. And ISVs and partners enable secure model deployments for their customers via Amazon SageMaker and AWS Marketplace. And it is really easy to get started. There are several videos you can watch to learn more. There are several sample Jupyter notebooks that you can try yourself. And then there are several blogs that show you how to use models, data products, and algorithms from AWS Marketplace. I also recommend you to check out the webpage for additional resources. And if you have any questions, please write to our team. And at this time, I would like to thank you for your time. It has been a pleasure presenting our insights to you today.